Pizza.
Today we're looking at finding the derivative of exponential functions.
Yay.
What are exponential functions? What do they look like?
They got an exponent.
Well,
Very
a lot of
low
stuff,
exponent.
that's the difference. A lot of stuff we've looked at has exponents, but exponential functions are when we have variables in the exponent. So, we're mainly going to be looking at the derivative of e to the x, but we will also look at finding the derivative of an exponential function of a base that has something besides e. But most of the time in calculus, if you're taking the derivative of an exponential function, it's going to be e to the x. And it is very simple.
Yeah.
The derivative of e to the x is e to the x.
What?
The derivative of e to the x is e to the x. So, that means if I have e to the g of x, the derivative of that is going to be
E to the g of x, g prime of x. Guessing.
that is correct. So the derivative of e to the g of x would be e to the g of x times g prime of x. So, let's do some examples. It moves pretty quick. So, Melody, what would the derivative of e to the 5x be?
E to the 5x times 5.
E to the 5x times 5, so we could write it as 5e to the 5x. Alright, then number 2, I have y equals 4e to the 1 minus 2x. What happens to that 4?
It stays.
It stays, so I've got the 4. What happens to the e to the 1 minus 2x?
It stays the same.
It stays the same. And then I need to multiply by
-2.
-2. Very good. So we end up with -8e to the 1 minus 2x. Alright, April, number 3.
E to the power of x squared minus 3x minus 1 times 2x minus 3.
Very good. Questions on that? There's 4.
Would be 2e to the square root of x times 1/2 x. Wait,
X to the 1 half.
what?
Just x to the 1 half, right?
If you rewrote it, it would be. That would be the derivative.
I don't know.
Anybody remember the shortcut on taking the derivative of square
1
root?
over 2 running left.
1 over 2 times the radical.
Then times the derivative.
Right, but there's nothing inside. So in this case, we're going to end up with e to the square root of x over the square root of x. All right, Zach, number 5.
Would that be would you simplify that first? So,
You could, but that'd take a little bit longer.
is it just e to the x plus e to the, I don't know.
Ryan, what's required on this one? What rule?
Oh.
What rule do I need on this one?
Change?
Chain rule. So I need to bring the 2 down. The inside stays the same. My new exponent is 1. Then the derivative of the inside, what would the derivative of the inside be? Just e to the x. Alright, Chris, what do I need to do on 6?
No, you gotta use the product rule.
So first times the derivative of the second plus the second times the derivative of the first.
C of x plus C of x. D of x.
Now, something on exponential functions, whenever you're taking the derivative and you're dealing with the product rule or the quotient rule, you will always be able to take the exponential part out. So, to clean this up, I would do e to the x times x plus 1. So anytime you're doing the quotient or the product, you should always be able to factor something out when you're dealing with the exponential stuff. Alright, Jasmine, number 7.
Cosine e to the x times e to the x.
Very good. Cosine e to the x times e to the x. Alright, Courtney, 8.
E
Very good. E to the sine of x times cosine of x. Alright, Melody, back to you on 9. What's required on 9? Quotient rule. So bottom times derivative of the top. What would the derivative of the top be, Melody?
4e to the 4x.
Minus the top times the derivative of the bottom over the bottom squared. And since we use the quotient rule, what should I be able to do?
11e to the 4x.
11e to the 4x. If I do that, that leaves me with 4x minus 1 over x squared. Alright, Amelia, 10.
Do you take the absolute value of what's inside?
You're thinking about it backwards. It's 1 over what's inside. Times the derivative of what's inside. Derivative of x is 1, and the derivative of e to the x is e to the x. So if I clean this up, 1 plus e to the x over x plus e to the x. Can I cancel the e to the x out?
No.
No. Alright, April 11. What would be helpful on 11?
Rewriting it as y equals e to the power of x to the 1/3.
Say it again.
E to the power of x to the 1/3.
Alright, and how can I rewrite that?
Oh, e to the power of x over 3.
Now that I have it rewritten, what would the derivative be?
X over 3. Wait, that's weird.
Very good. Jasmine says it'll be 1/3 e to the x over 3. Because the derivative of x over 3 is just 1/3. So I get 1/3 e to the x over 3. Alright, backside. Here's number 12. What type of differentiation do I have on 12?
I don't remember what it's called.
Implicit.
Implicit.
I have implicit.
That
I
one.
remember
Okay.
to do it though.
Alright, so Jairus, what do I have to do with x and e to the y?
First times the derivative of the second plus the second times the derivative of the first.
So what would the derivative of the second be?
E to the y times y prime.
Very good. So plus the second times the derivative of the first. Derivative of 8x is 8. Derivative of negative 3y is,
Negative 3y prime.
and the derivative of 0 is 0. Alright, what do I want to do at this point, Jairus?
Get y prime on one side.
Alright, so I have x e to the y prime, minus 3y prime. So that's going to equal negative e to the y minus 8. And then two things at once right here. What are those two things, Jairus? take out the y prime, and
Divide by.
divide by what's left. So I get negative e to the y minus 8 over x e to the y minus 3. All right, Zach, we want the second derivative on this, so what would the first derivative be?
E to the x minus, or plus e to the negative x.
Alright. So what does that mean the second derivative would be?
E to the x minus e to the negative x.
Say that again.
E to the x minus e to the negative x.
What do you notice about the second derivative?
It's the same as the first. Or same as the original.
What would the third derivative be?
The same as the first derivative.
Same as the first derivative. Alright, so that's how you handle derivatives when you're dealing with e to the x. Now we want to look at exponentials, but we want to deal with a base other than e. So we're talking about a. So to figure this one out, let's say I'm dealing with y equals a to the x. Okay, and let's say I don't know how to take the derivative of a to the x. What's something I can do to this to change it and make it not be an exponential function anymore? What'd you say?
Change it to the logarithm.
I want to take the log of both sides. In this case, we'll do the natural log. So I want to take the natural log of both sides. Once I take the natural log of both sides, what can I do with that x on the right? I can bring it to the front. Now I'm no longer dealing with an exponential function, and I should be able to take the derivative of it. So what's the derivative of the natural log of y?
1 over y.
1 over y, y prime. So that's the same thing as y prime over y. On the right side, it helps to realize that this natural log of a is just a what?
Constant.
It's a constant coefficient. So that means it stays, and what's the derivative of x? 1. So I just get the natural log of a. I want to get y prime by itself, so then I multiply over. But I don't want my answer in y. What can I replace y with?
A to the
A to the x. So that means the derivative of a to the x is
the
natural log of a times a to the x. What's the pattern there?
The natural log of the base
Times the original. That is correct. So to take the derivative of an exponential, it's the natural log of the base times the original. And actually, that's the same thing what we do with e. If we follow that same process with e, it would be the natural log of e times e to the x. And what is the natural log of e? 1. So we actually did the same thing to get that. Okay, so what changes when I put g to the x, or g of x in the exponent?
added g prime.
I added g prime to all that. So it's going to be
G prime times natural log.
g prime, natural log of the base, times the original. That's all there is to it. So we've got 3 more examples in one. So Ryan, on that first one, y equals 5 to the x, the derivative would be
ln 5 and 5dx.
Very good. ln 5 and then times 5 to the x. Alright, Chris, number 2.
Natural log of 3 times 3 to the x, x squared minus 2x times 2x minus 5.
Very good. Alright, then Jasmine on number 3. What's required on number 3? Product rule. So that's going to be first, which is x times the derivative of the second. So what would the derivative of the second be?
And I need the derivative of x negative.
And this is one more thing.
And the original.
No. Natural log of the base.
So,
Alright, so then plus the second, which is 6 to the negative x. And the derivative of the first would be 1. Now, we use the product rule with an exponential, so what should we be able to do?
Take out 6 to the
Take out the exponential. So 6 to the negative x comes out. And that leaves me with negative x ln 6 plus 1.
oh, you just moved it to the front.
First times derivative.
Because it came from that. If I take the 6 to the negative x out, what's left?
No, like whenever you
Going
take the
in.
derivative of it, you're doing the.
Right. But all I took the derivative of over here was the x. The negative you're talking about is right there in the middle.
So what happened to, how'd you get negative 1 from the natural log of the x?
Are you sure?
You take the derivative of the exponent, derivative of negative x is negative 1.
And then you just
You gotta do three things when you're taking the derivative of exponential. You gotta rewrite it, you need the derivative of the exponent, and you need natural log of the base. So those three things are what's going on there in the middle.
Oh, the x is right there.
Oh.
Never mind. Right there.
That's at the beginning, yeah.
Yeah, oh, you're talking about where did this x come from?
Yeah.
Yeah, it came from there.
Okay.
So, two things here. Derivative of an exponential involving e. How do I do that? It's a two-step process. What 2 steps? Involving e.
Rewrite it,
Rewrite it,
derivative of the x.
derivative of the exponent. So there's your 2-step process. It's a 3-step process if it's something other than e. Step 1 is
You can rewrite it.
Rewrite it.
Natural log.
natural log of the base and derivative of the exponent. Okay? But actually you're doing all 3 steps on e, except from the natural log of the base just always ends up giving me 1. So rewrite natural log of the base, derivative of the exponent when you're dealing with exponential derivatives of exponentials. Any questions? All right.